So let's continue with the mitigation techniques of GenAI, hallucination, reasoning error, and biases in software testing tasks. How you can mitigate any of these defects in GenAI outputs. So if we talk about the mitigation techniques of hallucination, reasoning error, and biases, to minimize the undesirable outcome of GenAI in software testing, you can apply certain strategies to reduce any of the hallucination that you are getting or reasoning error or biases. How you can do that with better prompt designing. So these issues usually will occur when you prompt just random information or your prompt doesn't provide the exact context. So the AI might hallucinate or have the reasoning error. So poorly designed prompts will have these hallucinations a lot. Or contextual input data is incomplete. You are using the contextual input data that is not complete. So any of these errors might occur because of these reasons. The techniques that are important to mitigate, or the techniques that you can use to mitigate these AI hallucination or reasoning error or biases are: you provide the complete context, first thing. Divide prompts into manageable segments, not trying to get everything all at once. Using clear, interpretable data formats. Select the appropriate GenAI model for the task. Not every GenAI model will be appropriate and relevant in your use case. So selecting the appropriate model. Comparing results across different models. So these are some of the techniques. Now let's discuss these techniques one by one. Providing complete context and use prompt chaining. So this becomes important. So when we say prompt chaining, it is basically dividing the prompts into manageable segments. That's prompt chaining, and we have understood about prompt chaining already. When we say complete context, whenever you are trying to prompt, you are trying to ask something, you are trying to fetch something or get some information from the GenAI, make sure you include all relevant information in your prompt. Okay. When you have complete context, all relevant information, then GenAI generates output which are aligned with the requirement. If you are trying to generate the test cases for the requirement, make sure you include your requirement, refer to the requirement. You in your prompt mention that you just stick to this requirement and do not provide any generalized output in that case. So whatever is mentioned in the requirement in the scenario, just stick to that and provide the test cases for that. So making sure the complete context is there, your requirements are there in the prompt. For example, poor prompt could look like generate test cases for login. This is just one liner for login. Obviously your generative AI model will hallucinate and will just provide the general information, general login test cases, whichever it has been trained on, or basically model based on its knowledge and thought process will provide you the login test cases. But if you say provide the complete context, say generate boundary test cases for login with username, and you provide the length 5 to 15 characters including valid and invalid inputs. Now this is also not very great prompt, but at least a lot better than just writing generate test cases for login, because you are saying for username which is of length 5 to 15 characters. Okay, so this is more clearer. Here as well we haven't included the password field. We should include the password field and all. So better prompt will provide you the complete context. Then dividing the prompt into manageable segment, which is also known as prompt chaining. So instead of asking everything all at once, prompting everything all at once, break your complex task into multiple steps, into smaller steps. So you start with prompt 1, you got the output, you then refine that output. So you started with another prompt. So prompt 1, prompt 2, prompt 3, until you get the desired outcome. Say for example, I say generate boundary test cases for login with username length this, including valid and invalid inputs. It will generate me the boundary test cases for login. Then I forgot the password. So in the next prompt I'll say also include the password field in the test cases which has the length of 5 to 15 characters. So this is what prompt chaining is all about. So you start with a smaller task. Based on the output, you analyze the output, then you start with another prompt, you write another prompt to refine the output until you get the desired result. So verify each output before moving forward. Detect reasoning errors early. So if you are getting reasoning errors, you will be able to detect those early because you are using prompt chaining. You are dividing the prompts into manageable segments, and step-by-step prompts are clearer and provide more reliable outputs. For example, you generate the login test cases, then that's the first prompt for example. Then you refine those login test cases for the edge cases, second prompt. Then you validate coverage against the requirement. Okay, so this is just an example on a high level. This is not actually or complete correct prompt or better prompt or best prompt. I'll show you the prompting techniques so that you can easily use those and avoid any of these errors in AI. Now, using clear formats and selecting the right model. That's another important bit. So, clear format, when we say interpretable data format, so avoid ambiguous format. You provide the structure. For example, straightforward format, you want the answer in the tabular format, in the list format, in the Gherkin scenarios. Provide that in your prompt, that you want the answer in the Gherkin syntax. You want test cases in the Gherkin syntax, in the tabular format. So ambiguous is create test cases for checkout scenario. Now whatever GenAI will think or whatever is common, it will provide your test cases for the checkout scenario in that. But if you are specific that you wanted the answer or you wanted the test cases into Gherkin syntax, you should specify that clearly in your prompt. Generate test cases in Gherkin syntax for checkout scenario with valid and invalid card numbers. Much clearer than the previous one. Not the best one, but clearer than the previous one. So clear interpretable data format. You want the data into JSON format, into Excel, how many columns, what sort of key ID pair should be there. That will provide you better results. Selecting the appropriate generative AI model. So not all LLM models are trained to do specific tasks. So if, say, for example, you are looking for the code suggestions, then there are models which are trained specifically on the coding or generating the code snippets and coding details for you. So choosing the LLMs trained for that specific task will provide you better results than the generalized model. Specialized model provide better accuracy because they are specially trained for that task and that criteria. For example, using a model fine-tuned for test automation rather than general chatbot. If you have a model that is fine-tuned for test automation, use that rather than general chatbot. Right format and right model will provide more focused and effective testware, and this way you can avoid any of these defects with generative AI, which is hallucination, biases, etc. Then comparing results across models, that's another very important thing. So you not only rely on one output, you compare results across different models. So for example, one model is providing you certain results, then you cross check those. You do the same prompt with other model, so you cross checking will help to detect errors and select most reliable results. You do same prompt in one model which, say for example, generated 10 test cases, login test cases. You use the same prompt into another model and another model generated 12 including additional edge cases. Now you compare both and then see which model is better, which model has provided you the better outcome in the context of your user stories or your requirement. Then you use that, or you combine the output from both and get the combined list of the test cases. So comparing result becomes really important to see which model is providing you the better outcome. Now benefits of comparing: reduces the risk of hallucination or biases slipping through. It provides confidence in the outputs because you have checked in multiple models. So you know that whatever test cases that you are documenting, whatever testware that you are getting from generative AI is actually correct, and it provides you more confidence in that. And then comparing across models provides extra safety in terms of the quality assurance. So that's all about the techniques that you can use to mitigate any of these defects in generative AI. Thank you. I'll see you in the next tutorial.